Now let's take a look at some concepts. Let's recall some concepts on polynomials and polynomial functions. All right. So let's recall that polynomials are a sum of what's called monomial terms. All right. Let's look at some quick examples. We've seen this in the past. So let's look at some quick examples of polynomials here. All right. So for example, we've seen something like 3x squared minus 5x plus 7. Right. Here's a polynomial of 3 terms. So it's called a trinomial, if you recall that, right? And the highest power is 2. So the highest power of the polynomial is called the degree of the polynomial, and the constant term is the one without the x term, just a number here basically, and it's going to be positive 7. So the constant is 7. The degree is 2. Now 3 is the coefficient of the highest degree term, so therefore 3 is called the leading coefficient. All right, so just some quick terms here. 3 is the leading coefficient. All right, and the highest power term is called the degree of the polynomial. Degree of polynomial. All right, and the last term, usually without the x term there, in this case by the variables, is the constant term. All right, so let's take a look at another one. How about something like 5x to the 4th minus 7x cubed plus 2x squared plus 9x minus 11, for example, right? So here is a polynomial of how many terms? 1, 2, 3, 4, 5 terms, right? So what is the degree of this polynomial? Well, highest degree is what? 4. So the degree of the polynomial is equal to 4. All right? And what is the 5 right here then? 5 is the leading coefficient. Once again, this is the leading coefficient. All right, leading coefficient of the polynomial. And what's the constant term? Well, right here at the end, right? The number term. So this is the constant. Now, our main focus, though, here is going to be what? Plugging numbers into these polynomials for x, for example, right? Or turning them into polynomial functions and plugging numbers in, right? So let's take a look at a problem like that, right? So for example, let's say you're given a function of f of x equal to, let's say the first one here, 3x squared minus 5x plus 7. All right, and you're asked to find, let's say, f of negative 2. All right, what does that mean again? That means you're going to plug in negative 2 for x to get the y value, or the function value, when x is equal to negative 2. So in other words, when the domain is negative 2, again, x, let's recall x is the domain, right? When the domain is negative 2, then what is the range? Well, let's plug it in to get that, right? So let's do that. So f of negative 2, again, this is not f times negative, make sure we say it correctly. F of negative 2 means what? Plug in negative 2 for x into this function, into this polynomial function. All right? So that's going to be equal to what? 3 times negative 2 squared minus 5 times negative 2 plus 7. All right? So let's work it out again. You could do it by calculator or by hand, doesn't matter. 3 times positive 4, because negative 2 squared is positive 4. This is plus 10, obviously, plus 7. All right? So that's going to be 12, 3 and 4, plus 10, plus 7, which is going to be what? 22 plus 7, 29. All right? So therefore, we're saying that f of negative 2 is equal to 29. So when the domain is negative 2, what's the range that corresponds to that? 29. All right? So this is just plugging numbers in to evaluate a polynomial function. No big deal. All right? Now let's just take a look at graphing these types of functions before we move on to adding and subtracting polynomials to wrap things up here. Let me go and clear out the screen. All right, so let's take a look at graphing these types of functions. So let's say, for example, I want you to graph the following polynomial function. Let's graph something like p of x is equal to something like x squared plus, let's make it plus 1, for example. Right? Something simple like that. Well, to graph polynomial functions, what you want to do is you want to make a table. Right? So let's make a table of x values and function values, p of x. Again, all we're doing is what? We're picking, just like we did for linear functions, right? Pick any x to plug in and work it out to get the y value. So let's pick x to be 0, for example, right? If I plug in 0 for x, so 0 squared plus 1, that's just going to be 1, right? Because 0 squared is 0. Let's pick 1 for x, right? Well, 1 squared is 1 plus 1 is going to be 2. Let's pick 2 for x. 2 squared is what? 4 plus 1, 5. And we see that hopefully you can see how I'm getting these function values by plugging it in without showing you the work. Right? Again, 2 squared is 4 plus 1 is 5. Let's try some negative values as well. So let's try negative 1 for x here, see what we get for y, or the function value that is. Right? Y is the function value, or the range value. So negative 1 squared, what's negative 1 squared? Well, negative number squared is positive, right? So that's going to be positive 1 plus 1. Let me show the work here. Negative 1 squared plus 1, right? That's a 2 right there, sorry about that, all right? Equal to positive 1 plus 1, or just 2 in this case, right? So the range is going to be 2 when the domain is negative 1. Let's try negative 2. 2 right there, sorry about that. All right, negative 2, again, plug it in, so we're going to get negative 2 squared plus 1, but again, that's positive 4 plus 1, and that's going to be 5. All right, so that's enough values here, but let's plot these ordered pairs, so because these are 5 ordered pairs, right? 0, 1 on the rectangular coordinate system, 1, 2, 2, 5, and so on, right? So we can plot these ordered pairs. Let me write these two, negative 1, 2. That's a 2 right there, sorry about that. And also a negative 2 and 5. All right? So let's plot these 5 ordered pairs and see what it looks like here on the grid. All right, so here's the y-axis. Here's the x-axis. All right, so we'll do the best we can here given the difficulty of the sketch pad. So 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3. 1, 2, and 3. All right, so 0, 1. So there's the first point, right? 1, 2, 1, 2 is this point right here, okay? 2, 5, 2, and 5 is all the way up here, all right? And negative 1, 2, negative 1, 2 is right here. And negative 2, 5 is going to be up here. All right, so again, now we connect these dots, but we connect them in a curved format because polynomial functions are nice and smooth functions. So don't draw straight lines, curve them a little bit. So here's what I mean by that. So I'm going to connect these guys there. Sorry about that. Missed it a little bit, kind of hard in the sketch pad. And curve it up right here. All right, so this is the graph of p of x. All right, so it's just later on we'll learn this is called a parabola in chapter 8, for example, or later on, right? Then that's going to be a parabola, and we have some properties on these as well, right? So to graph a polynomial function real quickly, again, we simply make a table, and we pick some positive x values and some negative x values to work them out and see what the rough sketch looks like, if you will. All right, now let's move on to adding and subtracting these polynomials, if you will. Let me go and clear out the screen. On adding and subtracting polynomials. Okay. Now we've already seen a little bit of that back in Math 30, so this section is somewhat reviewed for us here. All right. Now polynomials, think of polynomials as a sum of monomial terms. So let's look at some examples of polynomials here. Examples of polynomials. Polynomials are actually very useful to model real-life data. So often, if we have a bunch of sales data, for example, or a bunch of medical data, we can use polynomials to work with the data and then use them to predict future values, for example, future sales or future levels of cholesterol, for example, right? It depends on the application, but there are many real-life applications with polynomials, right? Let's look at some examples of polynomials here, if you will. So, all right. So we've seen these expressions before. For example, something like, for example, 3x plus 5. Right? Here's a polynomial. Here's a polynomial of two terms. All right. So these individual terms here are called monomials. So so a monomial can be what? It can be a number, right? It can be a variable, such as x, for example, and it can also be, in this case, a number times a variable, so 3 times x, right? So again, the individual terms, so the terms separated by the plus here, are called monomial terms. Okay, so let me say, these here are called monomial terms. Monomial terms. All right, so these individual terms are called monomial terms. Now, you may have and together that's called a polynomial, but a polynomial of two terms is called a binomial. Please recalling some terminology for you in terms of polynomials, but our main focus here is really on adding and subtracting these guys. All right, so let's look at a polynomial of three terms. What do we call that? For example, x squared minus 7x plus 1. Okay, so again, there are three monomial terms here. Okay, so what is that called? Well, that's called a trinomial. Now, I've given you polynomials of only one variable, but the reality is that polynomials can have many variables in them. Here's a polynomial of two variables, for example, 3x squared minus 4xy plus 7y squared, for example. Here's a polynomial. Here's a trinomial with what? Two variables, x and y, namely. So again, but the key is what? In order for it to be a polynomial, though, the individual monomial terms have to have powers that are what? That are whole numbers here. Okay, so for example, if I have something like 3x to the negative 2, for example, then that is not considered to be a monomial term, and therefore this whole thing is not a polynomial. So be careful with that. But basically, these expressions should look familiar to us from a previous math class, for example. All right, let's get right into adding and subtracting polynomials. Let me go ahead and clear the screen out. Okay, so this is a fairly short section here. Now, you'll want to add and subtract polynomials in a horizontal format, even though your book may provide the vertical format for you, but let's ignore that format and do it all horizontally, since I think it's not too difficult to do it, to add polynomials horizontally. So for example, let's say I want to add these two polynomials here. Negative 3x squared plus 5x minus 4, for example, all right, plus, so that's parentheses there, plus the polynomial 7x squared minus 10x plus 12. All right? So let's go and add up these polynomials. Now make sure you don't mistake this problem for a multiplication problem, because clearly you see the plus in the middle. If I took away the plus in the middle, then it will be a multiplication problem because of the parentheses. So in this case, don't let the parentheses throw you off. So all we do here to add polynomials, remember, is just combine like terms. So it's really no big deal. So first of all, let me go and drop the parentheses. So it's going to be negative 3x squared plus 5x minus 4 plus 7x squared minus 10x plus 12. All right? Now, let me combine like terms. But an optional step you might want to show on the homework is to rewrite this problem with the like terms next to each other. All right? So let's start with the x squared terms. So let's start with negative 3x squared. And here's another x squared term. So plus 7x squared. So put the x squared terms together. All right? Plus 5x, x terms. All right? Minus 10x. All right? And then minus 4 plus 12. All right? So I'm putting all the like terms next to each other. All right? And now all we do is combine like terms, which means we add their coefficients in this case. All right? Add or subtract their coefficients, depending on the problem there. So negative 3x squared plus 7x squared is going to be what? Positive 4x squared. All right? 5x minus 10x, well, that's negative 5x. All right, and then negative 4 plus 12, that's positive what? Positive 8. Okay, so again, not too bad at all. We simply combine like terms when we add polynomials, add or subtract in this case. All right, in this case, I'm just adding here. All right, let's go ahead and try another one. All right, let's look at something like this. Let's look at 8 8y squared. 8y squared minus 4xy plus 2x squared. All right, plus the polynomial 5x squared minus xy plus 4. Okay, let's close parentheses there. Okay, so suppose I want to add these two polynomials together. All right, again, just combine like terms, right? So now one thing about writing your final answer, well, I'll talk more about that in a moment. So let's go and combine like terms. Let me drop the parentheses. So 8y squared minus 4xy, there, sorry about that, plus 2x squared. All right, excuse me, and then plus 5x squared minus xy plus 4. Okay, just drop the parentheses again. Again, clearly we're adding these two together. Okay, let's combine my terms. So now, one thing you might want to do is alphabetize your variables. In other words, here I see y squared, but let's start. Why don't we start with the x squared first? So x comes before y in the alphabet, right? So let me start with 2x squared plus 5x squared. So let me write that. So 2x squared plus 5x squared, right? And then let me go to the xy terms first, if you will, next, if you will, all right? So because typically you'll want to, for the variables that are mixed together in this case, you want to write them first before the y squared term. So let me do that. So let me write the next two terms as minus 4xy, bring down the minus 4xy, and the minus xy, all right? And then we bring down the 8y squared finally, so plus 8y squared, all right? And then we always write the constant term last. So plus 4, bring that down as well. Okay? So then we combine like terms. So 2x squared plus 5x squared is going to be 7x squared. And then negative 4xy minus xy will be what? Minus 5xy. All right? And then plus 8y squared. There's nothing to combine there. And then bring down the plus 4 as well, the constant term. Okay, so that's our solution right down here. Okay, so again, just combine like terms carefully when we're adding polynomials here. Now, we're going to do it horizontally, and let's not do it vertically. So ignore the vertical format in your book here. Just do it horizontally. And actually, you can skip some of these steps I've shown here if you can do it in your head, because combining like terms is not too difficult if you remember from Math 30 here. Okay, let me fill out this screen. Let's look at a couple of subtraction problems before we move on here. Right. Let's look at subtracting polynomials. This requires one extra step. For example, let's say I want to subtract negative 9x squared, negative 9x squared plus 4x minus 8. This time I'm going to do a minus, so we're subtracting here, right? Minus the polynomial 3x squared minus 6x minus 4. All right? So how we go about subtracting two polynomials? Well, what the additional step here is that we have to what? If you remember, distribute this minus sign to this polynomial right here that we're subtracting. All right? So I need to distribute. Think of this as a minus 1 out here. Okay? And then distribute it to all the terms in that polynomial right here. Okay? This one will stay the same. So we get. So let's bring it down without parentheses. Negative 9x squared plus 4x minus 8. All right, now let me distribute the negative here. So negative, so opposite, I think this is opposite of this polynomial, right? Opposite of 3x squared will be what? Negative 3x squared. Opposite of negative 6x will be positive 6x. And then opposite of negative 4 will be what? Positive 4. All right? So again, just distribute the negative side to the second polynomial when we're subtracting. That's the only additional step we have. Now let me combine like terms without putting them next to each other. Okay? So for example, then we can do this in our head, right? Negative 9x squared minus 3x squared is what? That's going to be negative what? 12x squared. Okay? Make sure we see that. All right? How about 4x plus 6x? That's going to be what? 10x. All right. And how about negative 8 plus 4? Well, that's minus 4. Okay, so there's our solution right here. All right. So again, combining like terms is not too difficult, as you can see here. And let's try another one. let's look at this the difference of these two polynomials here. Let's look at 3x squared plus 6x plus 6x minus 1, all right, minus the polynomial negative 2x cubed plus 3x squared, excuse me, minus, let's make it 19x. Okay, so let's go and try to subtract these two polynomials here. All right, again, first one stays the same, just bring it down without parentheses, 3x squared plus 6x minus 1. All right, now again, I have to distribute the negative here, so opposite of negative 2x cubed will be what? Positive 2x cubed, all right? Opposite of 3x squared will be what? Negative 3x squared. And opposite of negative 19x will be positive 19x. Okay, so hopefully we can see that without too much trouble, all right? Now, typically for a polynomial, you want to start with the highest power term first. So what's the highest power term we have here? Excuse me. Well, it's the x cubed term, as you can see, right? So let's start with that. Any other x cubed terms? Well, there isn't, so let's bring that down. Bring down the 2x cubed. All right? And let's go to x squared terms. Well, we have 3x squared and negative x. Well, those are going to cancel out then, right? Right? They cancel each other off. So there are no x squared terms remaining, all right, in this problem. How about 6x and 19x? Well, that's going to be what? 25x. And then I have my constant term here, minus 1. Okay? So there's our solution here, 2x cubed plus 25x minus 1. All right? So again, not too bad at all here. Let's try one more problem here. Let me give you this example here. Let's see here. Here's a question for you here. What polynomial? Let's take our time on this. What polynomial must be added? Must be added. Okay, added to this polynomial here. Negative 6x squared plus 4x minus 3. What polynomial must be added to negative 6x squared plus 4x minus 3 to get the sum let's make the sum to be let's make it here about 10x squared minus x plus 5. Okay, so let's think about this question carefully. All right, so let's think about this question. What polynomial must be added to this polynomial to get this sum right here? So this is my sum right here. All right, I want to get this sum. So what polynomial? Let's call this polynomial p, for example. Right. All right. So I want p plus this polynomial here, negative 6x squared, right, plus 4x minus 3. Okay, and that sum should be what? Should be 10x squared minus x plus 5. Can we see that? What polynomial must be added to this polynomial? So p is our polynomial we're looking for, plus this polynomial to get this sum. All right? Now, how do I find p? Well, think about equations here for a second, right? Think of this as p plus some big variable. Let's call this big polynomial. Let's call this big polynomial q or something like that, right? So essentially, don't we have p plus q equal to this sum right here? This is my sum, right? This entire thing here is my sum. All right, equal to the sum. Well, if you want to find p, wouldn't you subtract q? Yeah, you would subtract q to both sides here. Okay. So what I'm trying to say is this: is that when you, in this case, if I want to solve for p, what I want to do is I want to subtract out this polynomial to both sides. Okay. So essentially, what I'm saying is that p is actually equal to the sum the sum minus q, but q is this big polynomial here. So the sum is what? This right here. So p is equal to what? 10x squared, 10x squared minus x plus 5, all right, minus q. Q is what? This entire thing here. So minus negative 6x squared plus 4x minus 3. Okay, so that's what we're saying here, essentially. Okay then, so this is really a subtraction problem, right? Let's distribute the minus sign. So let's bring down the 10x squared, the minus x, and the plus 5. The first polynomial stays the same. Distribute this negative here, so opposite of negative 6x squared is going to be what? Positive 6x squared, all right? Opposite of 4x will be what? Minus 4x. And opposite of negative 3 be what? Positive 3. Okay? Now let's go and combine like terms again. Let's do it in our head. 10x squared plus 6x squared is what? 16x squared. All right? And negative x minus 4x minus 5x. And then 5 and 3 is going to be what? Positive 8. Okay? So this is the polynomial we're looking for, right? So our polynomial is going to be this right here. So in other words, if I take 16x squared plus 5x plus 8, and I add it to negative 6x squared plus 4x minus 3, then I will get the sum as 10x squared minus x plus 5. So even though all the words here, added to, sum, indicate addition, this problem actually requires what? Subtraction, as you can see. Okay, so make sure we understand the logic of this question here. All right, let me give you some questions to post in Blackboard here. Let me go and clear out post the answers to some of these questions in Blackboard, okay? So in the discussion here. Let me go clear out the screen here, if you would. Okay? Now, before I do that, though, let me show you how to. Let me tell you how I want you to enter the exponents in Blackboard. Unless Blackboard has a mathematical feature, which it might have a math feature in there, which allows you to put in the exponents. But in case it does not, for example, let's say you get an answer as 3x to the 4th power minus 7x cubed plus 5x squared minus 6x plus 1. Let's say you get some answer like this when you post, when I give you a question here, and you want to post this answer to Blackboard. So assume that Blackboard doesn't have the math feature, which allows you to put in these exponents up here. Okay. So how do I put it in? Well, here's how you actually put it in. You put in 3x. You use this key right here. All right. There's a key here. This is under the number 6 button on your keyboard here. So 3x. This is the power key. So 3x to the 4. That's how you enter that. And then minus 7x. Again, this is the power key here. To the third. This button is you hit the shift and the 6 and number 6 to get this feature here. All right. And then plus 5x power key to the second. So again, this key here is called the caret key. This is the power key that we use as our standard here. Okay, minus 6x plus 1. So everything else stays the same. All right. But again, the power key is this caret key. If Blackboard doesn't have a math feature for you to enter the exponents here. All right. So that's how we would enter exponents when we submit the question, when we submit the answers to the questions I'll give you on Blackboard. Okay. So let's look at the questions that we have here. All right. Let me go ahead and put it right below right here. Okay. So post the answers to these questions in Blackboard. Okay. Let's go ahead and take the sum of these two polynomials. Negative 11x squared plus 4x minus 5 plus the polynomial negative 7x squared minus 6x minus 12. Okay, so let's try that one. Add basically combine like terms, right? Number 2. All right, number 2. Let's go ahead and look at this one here. Subtract these two polynomials here. Let's look at let's see here. Let's try x squared plus 6x minus 8 minus the polynomial negative 4x squared plus x minus 2. Okay, let's take the difference of these two polynomials here. And number 3, let's do one more here. Let's look at this third question here. The difference between what polynomial, right? The difference between what polynomial and and say 2x squared minus 4x plus 1 is the polynomial, let's make it 7x squared minus x plus 9. Okay, so the question is the difference between what polynomial, so if you have what polynomial and this polynomial, so the difference between what polynomial and 2x squared minus 4x plus 1 is this polynomial here is 7x squared minus x plus 9. Okay, so you can think about this question a little bit and figure out what polynomial that we need here. All right? If I take that polynomial and I subtract it, difference means subtract, like what polynomial minus this polynomial will give me this polynomial. Okay, so think about that carefully here. And so simplify these 3 problems here and post the answers in the discussion area on Blackboard. All right. Again, how do we enter the exponents? If we don't have the math feature available on Blackboard, then we use this caret key, which is under the number 6 button on your keyboard, to enter the powers. Okay. So until next time.